You can. I'll do them both ways today. Now, first problem says if f of x is a fourth degree polynomial, so fourth degree. When you say fourth degree polynomial, when you're talking about, it says has three complex numbers as roots. When you're talking about roots, that's the same name as zeros. And it says it has three complex numbers as roots. Now, a complex number has, for example, plus 3i minus 3i. Or try it again. We have plus 3i and minus 3i. These come in pairs. So then if I have a 5i, I'll automatically have a negative 5i. Like I say, they always come in pairs. So if it tells you that three of them are complex numbers, the other one has to be complex. And that would be your answer. I'm not sure the exact theory behind it, but if you were to solve a problem down, you would end up with potentially something that looks like this, like x squared is equal to negative 25. And when you drop the squared, then you put a plus or minus square root around the other side. This is a square root property. And it always has that plus or minus there. Now number 2 says what is I to the negative 3? Now our powers of I, we got I to the first is I, and if you have a negative 1 inside of a square root, that's going to give you an I. So to figure out what I squared is, if I square both sides, when I square a square root, they cancel each other away, so it gives me negative 1. And I to the second power is I squared. So that would tell us I squared is equal to negative 1. Now I to the third, to get I to the third, you take I to the first times I squared. So you show it over here instead of just saying it. Since these are both I to a power, you add the exponents. So I got 1 plus 2 gives us I to the third. So this times this gives you I to the third. So if I multiply what's on the right side, I times negative 1 gives you negative 1i or negative I. Now I to the fourth. If I take I squared times I squared, you add the exponents. So that would be 2 plus 2. That would give me I to the fourth. But if I look at what I squared is equal to, I squared is equal to negative 1. So that's the same as saying negative 1 times negative 1, which gives us a positive 1. Now the rest of them repeat. And what I mean by that is this would be equal to I, the same as this right here. This would be equal to negative 1, the same as this right here. And this would be equal to negative I, which is that right there. And that would be equal to 1. And then it goes on forever repeating that pattern. Now the only one we actually needed for this problem was I to the third. But this is I to the negative 3 power. Now we can't have negative exponents. So how we get rid of negative exponents is first it needs to be in fraction form, so I put it over 1. And we can move the I to the negative 3 to the denominator. When you move anything opposite of where it's at in a fraction, the sign of the exponent changes. So when we take the I to the negative 3 down to the denominator, it becomes I to the positive 3. Now since there's nothing left up on top, I automatically put a placeholder of 1 there. And from our chart, I to the third is negative I. So then 1 divided by negative I. Problem is we can't have an I in the denominator. So we have to simplify that. And how you get rid of an I in the denominator, you multiply the top and bottom by I. And you always do that. If you ever have a single I in your denominator, you just multiply by I. Now 1 times I is I. And negative I times I gives us negative I squared. But I squared from right here is equal to negative 1. So this would be a negative 1, which gives us I over positive 1, which gives us I. Does that make sense? Okay. You can, but you can't then easily evaluate it. So you immediately want to get rid of it by moving it opposite where it's at in a fraction. For example, if you had a problem that looked like this, we can't figure out how to handle a negative exponent. So almost always your first step in mathematics is to get rid of a negative exponent. So we'll take this 2 to the negative 4 and move it up on top. And it becomes 2 to the positive 4. And then 2 to the 4th over 1, 2 to the 4th, and 2 to the 4th would give you 16. So you're correct. We can't really do much with a negative exponent. So almost our first step is to get rid of that negative exponent. Now to do this, okay. Now to do this on the calculator, we want to do I to the negative 3. Now I is above your decimal. So if you do second decimal, it puts the I on your calculator. And then caret, that's this weird looking button here, negative 3, and press enter. And that gives you your answer. It's over on the right hand side. See right here? Yeah. Now this one right here, let me clear this off. We got f of x is equal to 5x to the 4th minus 173 x to the 3rd minus 16x squared minus 7x minus 15. Now this is in standard form. Standard form is when your terms are arranged from largest power down to smallest. This first term here is called your leading term. Now this problem's asking us, as x goes to positive infinity, the graph of this goes in what direction? How we determine that is based upon its leading term. Now it's got a coefficient. Coefficient is a number that's in front of it, which is 5, which is positive. It's either going to be positive or negative. Now your degree is your largest power of x, which also happens to be the power on the x. So your degree is 4, and this is specifically even. Now we got something called the leading coefficient test. And you have two possibilities here. You got where you're going to have an even degree, and you'll have where you have an odd degree. You'll have where you have a positive coefficient, and you'll have where you have a negative coefficient. And this is a table. So for this first box here, even degree and positive coefficient, this says up to the left, up to the right. Now if you got a positive coefficient and odd degree, it's down to the left, up to the right. In this box here, you got an even degree and negative coefficient. So it's down to the left, and it's down to the right. In this box here, you got a negative coefficient and odd degree. So it's up to the left, down to the right. Now, specifically in this problem, remember we said we got a positive coefficient and an even degree. So positive coefficient and even degree. So the description of what's happening as it goes clear to the left and clear to the right is it's going up to the left and up to the right. I don't know what this graph looks like, but I know as it goes clear to the left, it's going up forever. And as it's going clear to the right, it's going up forever. Now this says as x goes to infinity. Now here's my x-axis right here. So that's my x-axis. And over here is positive infinity, and over here is negative infinity. So this says as x goes to positive infinity. So we're looking to the right. Then it's asking, the graph of this goes in what direction? When it's going up, it's going to positive infinity. So that's why the answer here is positive infinity. Exactly. Mm-hmm. Mm-hmm. Now, okay. If a is equal to 2 plus I, and b is equal to 3 minus 2i, it says what's b times a, or b divided by a? Well, if we plug that in, we got 3 minus 2i over 2 plus I. Now, our standard form looks like this. Although they use A and B, let me choose different letters. M plus Ni. This is our standard form. This is the only way we can write our complex numbers. So we cannot have an I trapped in the denominator. So that's what's wrong with this. If you got two items in your denominator, and at least one of them is an I, then how you simplify that is you multiply the top and bottom by the conjugate of the bottom. So you're going to multiply the top and bottom by the 2 minus I. Now what I mean by the conjugate means the first part's the same, 2 and 2. The last part's the same, I and I. But the sign in the middle is different. See how this is a plus and this is a minus? These are conjugates of each other. So we'll take 3 minus 2i times 2 minus I. And down below we'll have 2 plus I times 2 minus I. Now this is foiling, multiplying binomials together. So we'll take 3 times 2 on top. Then we'll take 3 times negative I. This is the first, this is the outer. Inner, we'll take negative 2i times 2. And then last, we have negative 2i times negative I. Over, and then I'm going to multiply those together. 2 times 2, the first. 2 times negative I, that's the outer. I times 2, that's the inner. And I times negative I, that's the last. You feel good about the FOIL concept? Okay. So then 3 times 2 is 6. 3 times negative I is negative 3i. Negative 2i times 2 is negative 4i. And negative 2i times negative I is be a plus 2i squared. Now down below, 2 times 2 is 4. 2 times negative I is negative 2i. I times 2 is 2i. I times negative I is negative I squared. Negative 3i and negative 4i is negative 7i. I've erased the I chart, but I squared is equal to negative 1. So I replace the I squared with negative 1. Now negative 2i plus 2i cancels. And then minus, and then I squared down here is negative 1. That'll always happen with conjugates. Your middle parts will always fall away. All you have to multiply together in conjugates is the first and last of each. So all I do is multiply 2 times 2, which is 4, and I times negative I, which gives you the negative I squared. Now up here, we got 6 minus 7i. 2 times negative 1 is negative 2. And down here we got negative negative, which gives us a positive. Yeah. So then that gives us 4 minus 7i over 5. And we got 4/5 minus 7/5 I. And that's our answer. No. Yeah, you do. The standard form says they should be separate. Now, I'm not really that picky about it in my class, but that's when they're taking a written test. When you got a multiple choice test, it'll always be in this form. That's why you have to take it further. Now to put this in the calculator, sometimes it works, sometimes it doesn't. We'll put parentheses around the top and parentheses around the bottom. Excuse me. Other than that, we entered it exactly as you see it. So I'll do beginning parentheses, 3 minus 2i. And remember, I is second decimal. Closing parentheses divided by beginning parentheses, 2 plus I. So I typed in exactly as I saw it, just putting parentheses around the numerator, parentheses around the denominator. Now if I press enter, it'll give me this, which is decimal, and we never want decimal on these, so I'll do math, enter, enter. And you see how I get error data type? This is what I was talking about. Sometimes it works, sometimes it doesn't. I think it might be related to mode. Let me go to mode. No, I'm in A plus BI mode. Let me change it to real, see if that makes any difference. So I down arrowed to it and pressed enter on real. Okay, then do math, enter, enter. Nah, doesn't look like it's going to take it. I really don't know the connection between them, but sometimes it'll work, and sometimes it won't. Now I do know that after you get this right here, you can change each individual one by doing your 0.8, for example, this first part, and doing math, enter, enter. And that gives you your 4/5, this right here. And then the negative 1.4, if I do negative 1.4 and math, enter, enter, that gives me my negative 7/5, which is here. Some calculators will do that fine. It could be based upon the operating system that's on that particular calculator. Like if I did a second plus and chose the about, the first one, this has the version number of the software that's on here, and not all T84 pluses have the same version here. So, but anyway. Oh, to change it to a fraction? Yeah. Oh, that's yeah. If you do second, then decimals on this bottom row here. Mm-hmm. Right. Any written work that you put out there, it's you don't want to just put just the answer, but you have to put your steps. So that's where you'd want to put all this you see here. Now, in terms of anything that nobody else is viewing, like the peer grading, then you don't have to put that out there. Let me clear that off. Mm-hmm. Right. I can show that if you want. Okay, let me show you this one first. Right. Okay. Now it's asking what are the possible rational roots, or zeros. Roots and zeros are the same term. According to the rational root theorem, plus minus means plus or minus. Now we always label this number here at the end is P, and this number at the beginning is Q. Now there might be different letters in the book. I don't know about that. But that's what we'll call them. Now we're going to write down all the products to give us 15. We got 1 times 15, and we got 3 times 5. Now specifically we got a negative 15. Well, you could have a positive 1 times a negative 15 would give you a negative 15. Or you could have a negative 1 times a positive 15 would give you a negative 15. So how we handle all the different cases is we always put a plus or minus before each one of these. Now for Q, the only thing that'll give us 5 is 1 times 5. So I'll put 1 and 5 down with a plus or minus before each one of them. Now all of our possible rational roots, all of our possible answers is given by these combinations, P over Q. So we're going to take each value of P and put it over each value of Q. So I'll start here, 1 over 1. And you only need 1 plus or minus. 3 over 1. 5 over 1. And 15 over 1. So I took each value of P and put it over this value of Q. Then I'll take each one of these values and put it over 5. So I got 1 over 5, 3 over 5, 5 over 5, and 15 over 5. Now 1 over 1's 1, 3 over 1's 3, 5 over 1's 5, 15 over 1's 15, 1 over 5 is 1/5, 3 over 5 is 3/5. Now 5 over 5 is 1. I already wrote 1 down. 15 over 5 is 3, and I already wrote 3 down. So this would be our answer. And don't worry about what those represent yet. We'll talk more about that. Let's see, 1, 3, 5, 15. 1, 3, 5, 15. 1/5, 3/5. So it looks like C is the answer. Right. Way to figure out what possible answers you have. My computer's kind of slow on bringing up a word. This is what happens when you install updates. It puts things on there you don't want. I don't even know what a single Microsoft Office single image 2010 is, but it comes up no matter what now. Yeah, I don't know what came over me that day that I decided to put updates on my computer. But I should just install a new. I can get the software for free, but let's take a look at this one. Now, how do you feel about synthetic division? Oh no, it'll work every time. Did the book say it won't work? Oh, I know what you mean. In other sections, it doesn't work every time. Yeah, you're correct. It only works when you divide by x plus a number, or x minus a number. But it does work 100% of the time in these problems. Now this, we want to find all the zeros, find all the roots. So your first step is you want to list all your possible answers. And that's at p over q. So this is p, and the number that's in front of the x to the fifth will be our q. So all the numbers that give us 10 would be 1 and 10, 1 times 10, 2 times 5. And here we got 1 before the x to the third. Only thing gives us that is 1 times 1. So we'll just put a plus or minus 1. So then we'll have p over q. So we'll take each value of p and put it over q. So we got plus 1 over 1, plus or minus 2 over 1, plus or minus 5 over 1, plus or minus 10 over 1. Which means I got negative 1, positive 1, negative 2, positive 2, negative 5, positive 5, and negative 10, positive 10. Okay, now what we're going to do to find the zeros is we start with our first possible answer, and we want to plug it in synthetic division. Now this, remember, is x to the third, so we'll keep that in mind. So we'll add, multiply, add, multiply, add, multiply, add. And what we're looking for is we're looking for 0 for the remainder. We don't have 0 for the remainder, do we? Which means that's not one of our answers. We'll then go to our next possible answer, the 1, and plug it in. So we'll add, multiply, add, multiply, add, multiply, add. And again, we're looking for 0's remainder, and that's not 0. So that's not one of our answers. And then we'll plug in negative 2. The reason why synthetic division is preferred in this method is sometimes you have to do so many synthetic divisions that it would take you a long time if you did long division on every one of them. So add, you put zeros for missing powers. Like if you label your largest power x to the third, then this would be x squared, this would be x, and this would be our no x, our constant term. So if we were missing the x squared and the x, you'd put zeros here and zeros here. So let's put, yeah. Oh, okay. Now, always again, you identify your largest power, which is x to the third, and then you have one for each power going down. So x to the third, x squared, x, and our no x, our constant term, and you write down the number that's in front of each one of them. Now we'll go through a series of adding, multiplying over and over, and you start the first column, and you want to add. Now you got 1 plus nothing, so you just have 1. Or some people struggle with that. You just simply take whatever number's here and you bring it straight down. Now that's the add part. Now you always multiply by the number up in the box by the number you just put down here. So we'll take 2 times 1 gives us 2, and we put it here. And that's the multiply part. And then we want to add. Negative 4 plus 2 gives us negative 2. Is this good so far? Okay. So then you multiply. You always multiply by the number up in the box, by the number you put down here. So 2 times negative 2 gives us negative 4. And then you're going to add 9 and negative 4, it gives us 5. And then you want to multiply. You always multiply by the number up in the box, by the number you just put down here. So 2 times 5 is 10. And then you want to add negative 10 plus 10 is 0. Yeah. Now 0 here means you found an answer, which means that the number in the box here is our first answer. So x equals 2 would be our first answer. Now this was x to the third. This is 1 degree lower. So this will be x squared. This will be x. And this will be no x, our constant term. So after we find our first answer, we now have it down to the form of x squared minus 2x plus 5 equal to 0. Now at this point we could use a quadratic formula. With the quadratic formula, your a is whatever's in front of your x squared, which is 1. Your b is whatever's in front of your x, which is negative 2. And your c is a number at the end, which is 5. Now our quadratic formula says we got x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So we'll plug in. Our b was negative 2, so I'll put negative 2 in everywhere we had a b. Minus 4, a is 1, and c is 5. All over 2 times a, so 2 times 1. It gives us 2 plus or minus square root. Negative 2 squared is 4. Minus 4 times 1 times 5 is 20. Over 2. Which gives us 2 plus or minus square root of negative 16 over 2. Which gives us 2 plus or minus square root of negative 16. That's negative 1 times 4 times 4. Now remember with square roots, we're looking for a pair of somethings. Here's a pair of 4s, so they're going to come out as a single 4. And a negative 1 inside of a square root comes out as an I. So this becomes 2 plus or minus 4i over 2. Now standard form says if you have an I, you want to write the 2 separate. So we're going to have the real part. I'll put the 2 over 2 plus or minus, and then I'll put the 4 over the 2 with an I. And that's going to give us 1 plus or minus 2i. Now your fundamental theorem of algebra says your largest power tells you how many answers you're going to have, how many zeros, how many roots. Up here, our largest power is x to the third, and we found one answer with the synthetic division. That's this right here. And this plus or minus accounts for other 2 answers, 1 plus 2i and 1 minus 2i. But those will be our 3 answers. Only because it brought it down to the x squared level. I'm going to show you another example where we have to find 2 answers before we can get it down to that form. It'll make some more sense on the next problem. Right, I'm recording it now and I'll put it out there. Oh, you're not. Some people just don't ask and they just do bad. And I love students that ask. I'd much rather have that. Did you have any other questions on that one? Okay. Sometimes the math notation on all that makes it kind of complex, but it's a fairly simple idea, not necessarily a simple problem. Now let's look at this next one. We got x to the fourth minus x to the third plus 3x squared minus 9x minus 54 equals 0. And let's see what our possible answers are. This will be p here, and this will be q here. Now, finding the zeros, finding the roots is the same as setting it equal to 0 and solving it. And our largest power is x to the fourth, which means we're going to have 4 answers. I'm not sure if I see this one. 1 times 54. 2 times 27. 3 times something. Let's see, 18? Okay. 4, no. 5, no. 6 times 9. Now our q is just 1, so that's the only thing gives you 1 is 1 times 1. Now to save a little bit of space, I'll do this, I'll just say it. P over q, 1 over 1's 1. 2 over 1's 2. 3 over 1's 3. 6 over 1's 6. 9 over 1 is 9. 18 over 1 is 18. 27 over 1's 27. 54 over 1's 54. And these are all of our possible answers. So first thing I'm going to do is I'm going to start with, I don't know, negative 1, I guess. And I want to plug those into synthetic division. Now notice here, our largest power is x to the fourth. So real small across the top I'm right, x to the fourth, x to the third, x squared, x, and no x. Now you asked when do we drop out of synthetic division. This is going to answer that question a lot better than the last example. So add, multiply. You always multiply by number of the box, by number you put down here. Negative 1 times 1 is negative 1. Add, it's negative 2. Multiply, negative 1 times negative 2 is 2. Add, 3 plus 2 is 5. Multiply, negative 1 times 5 is negative 5. Add, negative 14. Multiply, add. No, that doesn't work. So we go on to the next one, 1. So add, multiply, add. Do you feel good about the synthetic division part? Okay, I'll go a little bit faster on that then. Oops. Negative 60, so that doesn't work. So we go to our next one, which is negative 2. Now after you get this process down, books will give you hints on which numbers do you not even need to try, because there's not even a possibility. Now when I go through and do this one, you notice that I get a zeros remainder, assuming I did all my basic math right. Since I found a 0, that means that the number in the box is our first answer. So our first answer is x equals negative 2. Now this was x to the fourth, and that took it down to x to the third. Now there's nothing saying that answer doesn't repeat. So we're going to try negative 2 again, but the line we're going to work with from now on is this right here. So after you find your first answer, then you work with the new line. And again, this is my x to the third, this is x squared, this is x, and this is my no x. Right, and at that point, then it drops down to x to the third. Well, no, after you find your first answer, it isn't just specifically for x to the fourth, it's just your first answer, and it transforms the entire line then. So then, if I add, multiply, add, multiply, add, multiply, that doesn't work. Doesn't give us zeros remainder. So I go to my next number, which was positive 2, I guess. And again, I want to make sure, very important note here, you always want to use this line you just found, that's what I circled there. You never want to go back to your original line after you find your first answer. Add, multiply, add, multiply, add, multiply. That doesn't work. Go to negative 3. Add, multiply, add, multiply, add. Doesn't work. Then I go to positive 3. So add, multiply, add, multiply, add, multiply, add. Now notice what we found. We found another remainder of 0, which means we found our second answer. Now each answer you find takes it down one more power. So this was x to the third. We're now down to x squared, and this is x, and this is our no x, our constant term. So in response to your question, when do you drop out of synthetic division? Once you get down to x squared, that's when you drop out. Or there's other techniques also. Now the 0 you always ignore, so this is just x squared plus 9. And this one, the square root property would work real well, because we can take the 9 over, it becomes a negative 9. And square root property says if you have something squared equal to something else, you drop your squared, and you put a plus or minus square root on the other side. And negative 9 is negative 1 times 3 times 3. So the pair of 3's comes out as a single 3, and the negative 1 comes out as an I. So our answers, up above we said x equals negative 2 is 1, x is equal to 3 is 1, and then plus or minus 3i is our other two answers. Because that plus or minus means there's two answers there. And I think I got a video on doing that by hand that I can put out there. So I'll put that out after we're done so you can see it. I'll put it under the announcements location again. Okay. Well, I'll put the video out there and any other videos that might help, and then put this one out there once it gets done processing. Mm-hmm. Well, like I say, it's left up to interpretation on that. Now, the way I would interpret it, that doesn't mean it's the correct way. There's different ways you can think of that problem. Is says if a stock price goes from $10 to $12 from January 1st to January 31st. Then 12 to 9 from February 1st to February 28th is the price change from 10 to 9, a straight line. So if I go with putting my day of the month here, $10, and then from that to 31st would be $12. This is January. And for February, first it's from $10, and then to $9. If I found a slope of each one of these, this would be 12 minus 10 over 31 minus 1, which would give us 2 over 30, or 1 over 15. This one, if I did 9 minus 10 over 28 minus 1, that would give us negative 1 over 27. Now, assuming I wrote these points down right, these do not have the same slope. And if you got two lines that are different slopes, then even if they met here, then they would look like this. So it would never be a straight line. Let's see. Okay, stock price is a price change from $10 to $9, a straight line. Now this is the way I would interpret it. You could also take these and put them like the days that passed since the beginning of the year. So this would still be 1, this should be 31, but February 1st then would be 32. And then from 32 to 59, you can think of it as one continuous segment there. But again, from the fact that these had different slopes, they still wouldn't be a straight line from the beginning to the end. Does that make sense? Oh, did I wrote that down wrong, didn't I? This should have been 12, shouldn't have. Well, my eyes are bad. And that's 9. Okay, let's try that. Just to make sure okay, so 9 minus 12 over, what was that originally? 28 minus 1. So that gives you a negative 3 over 27, which again doesn't match the slope. Yeah, so it means the slope from this first segment will be different from this. But again, there's lots of ways to interpret that. Now it says, how can I use two pieces of lines to describe the price moves from the beginning of January to the end of February? This is a piecewise function. When it's different right here, then I could come up with whatever this line is, and I could come up with whatever this line is after I find a slope. And then I could say this is from the days of the year. This might be like where T goes from 1 to 31. And this one would be where T goes from 32 to 59. And that's what they're kind of implying. They kind of answer the question on this second part. When they tell you that, you know, how would you describe the price movements? Well, that's a piecewise function when this piece does not equal this piece. Does that make sense? But like I say, I'm not saying I'm right. There's different ways you could interpret that. But especially since stock prices never go consistently in a straight line. You know, we know the stock prices have to be going like that. Right. Right. Yeah, and really, if you're going to model it, like you say, your best bet, you could go with your first and your last, and you could come up the line between them, which would be a straight line then. There's actually a business technique, if you go into economics or finance, of smoothing out the data, where if it was all over the place like this, you could smooth it out so you can come up with a model you could use to predict. It's right, and that's called right. That's called exponential smoothing that does that. Okay. Well, I'll save this video then and I'll upload it. Have a good night.